Hi, my name is Patrick Desjardins, and in today's episode, we will try to confine in 30 minutes a TypeScript tutorial on the basic and most important topics to get started. I've been using TypeScript since 2014 at Microsoft, and since then, have touched many iterations of the language. Throughout these years, I have noticed a few elements that I am using on a daily basis, while others are more advanced for edge cases. If you are not yet convinced about TypeScript, here are the three main advantages before exploring TypeScript coding features. TypeScript's transpilation lets you catch bugs at design time. Transpilation is the process of taking the TypeScript code and producing a JavaScript file. During the process, TypeScript analyzes your code and provides recommendations and errors to fix. Design time is the time when writing your code. The small feedback loop between the moment you type and the moment you get what is wrong allows you to be more productive by avoiding error at runtime. The second advantage is the low learning curve. TypeScript is a superset of JavaScript. Being a superset means it adds on top of JavaScript types and capability to simplify our development life. It is a language that follows JavaScript's evolution. All your existing JavaScript knowledge is transferable automatically when you start using TypeScript. Also, the learning curve is reduced because you will have autocomplete while writing your code. That's right. When using TypeScript, you get the tooling able to give you information about types. Finally, TypeScripts allow us to transpile into any version of JavaScript. The transpilation phase lets you use the future or present features of JavaScript and have the JavaScripts produced into a legit ECMAScript format. ECMAScript is the standard associated with a version of the JavaScript. Older browsers don't support all the new features because they are running on an older ECMAScript standard. With TypeScript, we can target an older version and have a generated JavaScript that will work for older or recent environment. It means you can use everything you need and want, even if they are very new, into an older browser. The trick TypeScript is using is finding polyfill, which is an alternative code to mimic a native feature of a more recent version using older JavaScript code. With all the positives stated, now we need to get started. TypeScript is supported by many platforms and a variety of softwares. I am using VS Code in this tutorial and in my day-to-day code job. VS Code is also known as Visual Studio Code. It is built by Microsoft. It is free and it has excellent support of TypeScript. While you could code in any text editor and use the console to generate TypeScript, having a software with TypeScript's integration allows your code to benefit from autocomplete and to have marks of error directly into your code. The first step is to acquire TypeScript. If you are developing with JavaScript, you may have heard of NPM tool, which is coming with NodeJS as a package utility to get an external third-party library. TypeScript is one of them. I will assume that you have NodeJS downloaded. If you do not have NodeJS, you need to look up on the internet and download it and install it. Once installed, you have NPM installed as well. We need to use NPM init to create a package.json file. This is not related to TypeScript, but will let us have TypeScript described for the project with the version we want to use. Typing npm install --save-dev TypeScript will download TypeScript for us. TypeScript comes with VS Code, and it is possible for you to determine which TypeScript version you want for your VS Code by clicking at the bottom of the screen. You can use the default version for VS Code or the one you have downloaded in the package JSON. I would recommend you use the NPM version. What is the difference? The one in VS Code will dictate how the autocomplete and error detections are performed while you write your code in real time. However, the one downloaded in the package JSON will be the one used during transpilation. Having the same version will give you the same error inside the editor than at the transpilation. To test what we have, we can create a new TypeScript file called example.ts. Because TypeScript can be configured in many ways, we need a configuration file. You could skip the configuration file and pass the argument to the tool directly. However, every project that are using TypeScript has a tsconfig.json, since it is a convenient way to share the configuration among teammates in a team. And also, it allows us to have a shorter command line to execute. We can type TSC, which is a TypeScript compiler that will transpile all TS into GS file. So let's use the tsc-init. It will produce a detailed tsconfig JSON file. The configuration file is rarely modified once configured at the beginning of a project. The most important fields are target, module, lib, and out there. Other configurations default are quite right. For example, the strict is true by default. It means that TypeScript will apply rules more strictly if you get started. You can set it to false and adjust manually each rule. But it is a better approach, in my opinion, to get all strict and learn how to have a safer code from the start. Don't worry, TypeScript will let you know when something is not following a rule by having an error in the problems panel of VS Code or when you compile. The important configuration, like the target, will let you determine what flavor of JavaScript to produce. The target changes the ECMAScript compatibility. By default, the ES5 is selected at the moment. Changing to ES3 or any older version will produce a different JavaScript code. For example, we can use the basic const phone equal 1, 2, 3 with underscore. And the transpile code will be using var and remove the underscores. If we change the target to be ES next instead of ES3 and execute TSC again, we see that the code kept the const keyword because it is the feature inside the latest ECMAScript but wasn't at the ES3 time. The other configuration that is important is the lib. If you are using Node to create a server or application not related to the web, you do not need all the typing for the web functions. But if you do, then you need to add the DOM in the lib. Similarly, you can cherry-pick features from ECMAScript that you desire, like using es2020.promise. That is rarely something you need to adjust, only if you are stuck that you want to use something and TypeScript cannot find it. Then you might want to get into the configurations and add the lib. The last one is out there. As we can see, the example.js was generated next to the TypeScript file, which makes our code base not tidy. The best way is to have all TypeScripts transpile into an output directory. The output directory is what you need to publish on your web server or your release code. You do not release on internet your TypeScript file. You do not run or execute your TypeScript file. TypeScript is a tool to produce the output. So we can have our code inside a directory by adding the out there. Running the same tsc command, we can see that we have not an out folder with example.js. We can delete the old JavaScript file and keep having our code separated between the working files and the output files. Finally, the module needs to be set to CommonJS for most Node.js work and to ESNext or any ES for web project. In short, it changes the way files are interconnected between them. There are two different standards, and one is compatible with Node.js on a machine, while the latter is compatible with web browsers. So now let's start with the language with the autocomplete, which provides an inline documentation. If we go back in the example.ts and we erase everything and create an array of string that contains 3 strings, we can see that if I move my cursor above the name of the array that specifies string, TypeScript has the capability to infer types. For example, if I write const and equal 1, the type will be 1, not number, because TypeScript determines that the value is a constant and cannot be something else than 1. However, declaring with let instead of const will change the type to number. The type is a primitive type of JavaScript that we can visualize when we execute the code with the JavaScript function typeOf. If we console.log out the output of the typeOf, we will see that at runtime we have a number. Then we use node to execute the out example1.js, and we can see a number. So TypeScript is borrowing the existing type and will add on top what is missing from JavaScript. Let's move back to the array. Instead of having TypeScript infer the type, we can explicitly mark the type using the colon with the mention of string and the square brackets, which means an array of string. If you type string without the brackets, TypeScript produces an error saying that it was expecting a string, but a collection was provided. Now we can add to the list an item using the push function of the array. See how TypeScript provides an autocomplete of the function and how it accepts a parameter? We can see that the push also returns a number. Great! Might not be useful now, but we can see that it is auto-documenting in the process of writing our code. At any time, you can press F12, which means go to the definition. It's a quick way to go in the definition file. A definition file is a .d.ts file that comes with a library written in JavaScript or the core ECMAScript libs. For example, pressing F12 on the push function will lead us to the lib.es5.d.ts because of the target chosen in the tsconfig.json file, to the push function, where we can read the comments and see the signature. At the time of this recording, many third-party libraries come with the .d.ts file, so using npm to install the library comes with the typing. For the case where there is no definition file, there is a way to get popular libraries from an open source GitHub repository. It is free and required to use npm and install the library with @types/ before the name of the library. For example, we can download the node types using npm install --save-dev @types/node. The downloaded definition contains only the types and function signatures, no executable code. Thus, it is solely useful during development. The real JavaScript library is required for executing the actual logic. As we briefly examine, TypeScript has the ability to infer types from usage. If we create a function that takes 2 parameters and return the sum of the 2 parameters, TypeScript, if we are in the strict mode, will complain that we cannot have implicit any. Any is the type that you can set any kind of value. It is a bad practice, and the default infer type in a situation that any variety of types could be used. For example, if we have a function using the plus sign of the 2 any variables and try to add the string 2 and number 1, we will get something odd, which is 21, because JavaScript concatenates with the 2 string, of the number. Let's improve the code by expecting a number as a result by adding the colon for the return time of the function. The change causes the variable type to change to a number as well, but the result remains 21. The reason is that we are telling the type of the function's output, and it's determined with the combination of any and number. We cannot convert from any to any type because TypeScript knows that it can only be more specific. Let's set the input parameter as a string for the first parameter only. Suddenly, TypeScript mentioned that the return type cannot be number because now the string plus any is not convertible to a number. Changing both to string caused the same issue. What we want is to have the return type to string, or to have both parameters to numbers. Having both parameters to number creates an error on the first input of the function call. TypeScript lets us know that we have a typing error at the invocation because we are passing a string instead of a number. Changing the value to a number and compiling and executing show us the value of 3, what we are expecting. We are going pretty fast, but let's jump into creating our own type with interface. With an interface, you define how an object will need to regard in terms of field's name and value. Let's create a house interface with the street number and a street name field. One field is a number and the other one is a string. We can have an object by passing the name we specified for the interface after a colon. I'm creating one house with the number 1 and the name ABC. The autocomplete provides us a list of fields that must be present. In our case, the street number and street name. If you need to have a field optional, you need to use the question mark. For example, adding new house in the interface does not invoke an error if we have a question mark, because it is optional. Going to the object, we can see the optional field. I can add the field without having an error. The same if I remove this field. However, if I remove the integration point in the interface for the optional field, it becomes a required field, and an error arises. Two details here with an interface. An interface can be changed into a type if you use the equal notation. Type is less flexible than interface, and it is better to rely on an interface. One flexibility that an interface provides that is not possible with types is that you can enhance the type by redefining it more than once. Let's first change the house to a type, then create a person interface. The person interface with only an ID. Then the same interface, which could be in any files, even outside the library, and let's add a name. As you can see, creating a new person will need to have the field ID and the field name. In short, rely on interface most of the time. The usage of type is interesting when defining a list of values that we want to allow, or when intersecting types, which is a more advanced topic that we will cover later. Here is a quick type that accepts two values, movie and TV, which are two possible values accepted for the person hobby. Now, we have an exception in the person object because the hobby field is missing. Typing hobby, we can see that TypeScript gives the two possible values. Anything outside determined string will be an error. Last detail about an interface, you can extend an interface using the keyword extends. For example, both person and house can have an ID. We can have an interface name based model with the ID field and have both types extend the base model. The idea is to avoid repetition and increase the reusability of types. Now that we have a house as a type instead of an interface to have the ID, we need to create an intersection of type using the ampersand. It means that we will have the object definition between the curly brace and all fields in the base model. We get an error which is expected until we set the ID to the house. Let's introduce Enum type with a change to our hobby type. An Enum lets you have a descriptive label to a value. For example, we could want TV and movie to be with numerical ID like 100 and 200. Now we can change the person by typing hobby and period. The type of a person is hobby, which allows to label TV or movie and set the numerical value. If we print the object in the console, we can see that we have a hobby to 100 because we set the label TV. With Enum, we have a few advantages. First, if we do not set a number, it will start from 0 and increase automatically by 1. For example, the same code as before, when removing the values, we'll have an object with the value 0 during the execution. We can also have a string value that can be any string. In this example, we can alter the enum for TV to add TVVVVVV, and for movie, we can use movie. The difference does not appear now, but if we are printing the value with a console.log, the hobby would change from the numeric value to the string. Let's print and see. The next topic is generic. There are many times when we want to have many types to get into an object, and that we might not know the type, but only its surrounding. For example, we can create a function that takes any kind of object and return the object with an added ID field. Without generic, the add ID that takes an object will return an object. We won't have any code completion. Let's remove the ID field from the house by removing the extend to model base. We do now have a house with only street name and street address. We use the function that creates a new type with an intersection of house and an anonymous type with an ID. But when using the new variable and pressing the period, we do not have any result. The type is implicit to any. Even if we add explicitly a return type with the ID. To keep the person type with the intersection, we need a new type generated on the fly. Because we want more than just using the function for the house or the person, we cannot really change the object type from any to house or person. If we do, we can see that we have access to all members of the house or the person. But what if we want to use it with all types, like the person and the house at the same time? This is where we use the bracket around generic type. By convention, it is often T or something small, but we could use any name. Let's use TObj. The change lets us using the new variable with the 3 fields. We can be explicit if desired by specifying the type to be TObj ampersand ID number. But what is even better is to use TObj and base model. It means that if in the future we are altering the base model, that the function will be adjusted to the expectation of the base type with the new field. For example, let's add created date in the base model. We automatically see TypeScript saying that the add ID with the generic does not return the date. The date created is not optional, hence required, and TypeScript knows that we are not specifying that value. We can add created date new date, and we're going to be good. A quick glimpse into the optional parameter, we can also define a default value to the ID value of the function by setting equal and the desired value. Let's put 1. Now, if we go back to the add ID invocation, we can see that the ID value has an interrogation point. meaning optional. If not defined, the value will be 1, since it is in the signature of the function. An epitome of generic is a list of elements of generic type, meaning that we want a list to have all its features like adding, searching, deleting, and specifying the type when needed. It is possible in TypeScript to create a type list with the square bracket and having the type defined before, or use the array under a bracket. Pressing F12 to the array, we go into the ECMAScript definition file and see is used. Then we see if we use pop and get t or undefined t. Will be defined type. In our example, a number or undefined. If nothing is to pop in the list. There's the notion of tuple, which is a list with predefined size and types for each element. If we erase everything and we create a tuple that for a boolean, a number, and a string, it will look like the following. Let's create a function that returns the tuple. The variable that will receive the tuple is not a list. It is a tuple of a boolean, number, and string only. We can change the value as long as it's the same type and the same size. I'll close up this basic TypeScript tutorial with classes. TypeScript is a language that supports functional programming as well as object-oriented. It is possible to have class keyword and the name, similarly to an interface. The difference is that we need to instantiate the class. All object-oriented features like extending or implementing are present. An abstract class is possible with the constructors, public, private, and protected fields. Changing from ES6 to ES3 shows a big difference where a recent version of ECMAScript generates a class, while the ES3 generates a function. We can see the difference output if we change the tsconfig.json and the target, as I am demonstrating now. In this tutorial, we saw how we get started with TypeScript. We had a quick overview of the basic elements that you may use when you get started. I hope you appreciate the video and feel free to subscribe if you want to get new TypeScript videos and web developments video on your YouTube homepage. If you liked this video, feel free to click like. See you soon.